Welcome to Spring LIB.
A particle under a net force, if a particle of mass m experiences a non-zero net force, its acceleration is related to the net force by Newton's second law. We can write F is equal to ma, that we know already. Let's say it equation number 1. Now the isolated system energy, if no non-conservative forces act within a system, the mechanical energy of the system is conserved. So in that case, we can write K of I plus U of I is equal to K of F plus U of F. Let's say equation number 2. Here K is kinetic energy, U is potential energy, I represent initial state and F represent final state. Now the speed of a wave on a stretched string is set by the properties of the string. Tension T and mass per unit length mu is given by the formula V is equal to square root of T upon mu. Let's say equation number 3. Here given data are mass of the block is m, unstretched the length of the cord is L0, mass of the cord is m, and force constant of the cord is k. Now the required data in part A, we are asked to find the tension T in the cord at the lowest point B. In part B, we are asked to find the length L of the cord in the stretched position. And in part C, we are asked to find the speed v of the transverse waves in the cord provided that the block is held in the lowest position. So let's move towards the solution. Now, we define the earth, the block, the core as our system. Since there are no external forces acting on the system, we can model it as an isolated system for energy and apply equation 2 at points A and B. So in that case, I can write K of A plus UA is equal to KB plus UB. Now substitute for energies, recognizing that there are two types of potential energies: elastic potential energy in the core and gravitational potential energy in the earth block system. Also, we neglect the mass of the core so that the only kinetic energy in the system is that of the block. The kinetic energy of the block is zero at both points since it is released from rest at point A and stops momentarily at point B. So we can write 0 plus 0 plus mg delta x is equal to 0 plus 1 half k delta x square. Now simplifying further and write the whole formula in the form of delta x, we will get 2mg over k. Here instead of small m we have changed it to notation capital M as we know the mass is m. Hence the length of the cord in the stretched position can be calculated as L is equal to L0 plus delta x. Now we have delta x that we will put it in this equation. So L will be L0 plus 2mg over k. Let's say this equation as a phi. Now, the speed of the transverse wave is found from equation 3. As we know, our equation 3 is v is equal to square root of t over mu. Now we are going to substitute m by L for mu. So we will have square root of t upon m upon mu. So we will have, that will be a t upon, m upon L, not the mu, because instead of mu we are putting this value. So mu is equal to m by L. So here that will be L. So the answer will be TL upon M. Now substitute for T from equation 4 and for L from equation 5. We will get the V. So we will have V is equal to square root of, as we know, T is equal to 2 mg upon M times L0 plus, because we have L is equal to L0 plus 2 mg upon K. So this one is the speed of the transverse wave.